I'm Lucas Marion with Computer World, and I'm here today with Yuval Boger from YCharge. You're the Chief Marketing Officer there?
That's correct. Hey,
All
Lucas.
right. Good to see you.
Likewise.
You're going to demonstrate for us today infrared charging technology. Is that correct?
Absolutely.
So first, why don't you tell me what it's called and how it works?
So the company's called YCharge. We use infrared light to deliver energy from a distance. We can charge a phone across the room. We can see that today.
Okay.
And then this technology can basically replace batteries. If you have a battery-operated device, you no longer have to think about replacing the batteries. You can just deliver power using YCharge technology. And of course, it can replace power cords. So if you have a wireless speaker that you want to hang on the wall, the wireless speaker already gets the music through Bluetooth or Wi-Fi, and now you say, well, how do I route this ugly power cord? You may not have to do that anymore because you can get the energy wirelessly.
Okay, that's very cool. Tell me a little bit about the limitations of this. So for example, you talked about distance. What are we talking about in terms of how far away this could charge something?
So today we have two models. One that focuses more on IoT devices. This could be smart home devices. It could be sensors in smart buildings. Can power
Maybe
some of the devices.
Fire alarm or?
Exactly.
Okay.
Or for instance, a smart door lock. You have these door locks that are starting to say, oh, we've got biometric sensor, or maybe we've got a camera for face recognition. But these door locks are battery operated. And because they're battery operated, two things happen. One, the consumer is requested to replace the battery every couple of months or risk being locked out of their home, which is not good. But more importantly, the door lock manufacturer is limited in the functionality that it can put in the door lock because there's no battery. So for instance, a lot of people come and say, when someone approaches my door, I would like a 3-second video of that person recorded and being uploaded to the cloud so that I could see who was there.
Right.
Well, that doesn't happen today because taking a 3-second video, compressing it, turning on Wi-Fi, logging into the cloud, and uploading takes energy.
Yeah.
And so by adding YCharge technology to a smart door lock, not only can you get rid of replacing the batteries, but it opens up all these opportunities for enhancing the device.
Okay, and most importantly, as consumers, we want you to be able to charge our smartwatches, our smartphones, and all that stuff. How is that going to work?
So the thing with, so first let me show you how it works. I
Okay.
mean, so this is the, right here on the ceiling, we've got the YCharge energy transmitter. What I'm holding here in my hand is an energy receiver.
Right.
You can see it's got a micro USB port in this particular model that's really easy to integrate. So here I've got a Samsung 7 phone.
Okay.
Nothing special about it. You connect the transmitter, the receiver to it, and now you'll see in a couple of seconds, there you go. The phone is charging.
So it acquires the chipset in here, the antenna, essentially. It recognizes it and then starts transmitting the power.
So what the receiver has is a photovoltaic cell. It's like a little solar cell. The transmitter searches in the room for devices that it could power, and then once it finds that device, it sends a really thin, very focused beam of infrared light, invisible light, and delivers that power. And as you can see, that's enough power to charge the phone. That's enough power to get the phone started.
It's charging right now?
It is charging right now. It says it's charging.
And then what happens if something comes between it? Does that cancel it out?
So when something comes between it, the charging stops momentarily, and then it can resume. I think an even easier way to show it is I'll just take this light strip.
All right.
There's nothing here. You know, there's no battery, just a bunch of LEDs.
Sure.
Can put the same transmitter, the same receiver on it. Now it's going to take a couple of seconds to acquire it, and now that light is on. By the way, you know, I can move this around and there's no problem, right?
Okay, because
now,
the beam
as soon as I
tracks
do
with
that, it's off, and then now it reacquired it.
Okay.
And that can move around, you know, to a lot of distances. By the way, the other thing is that this receiver can also be placed on moving objects. So here I have a Lego train. I installed that receiver. That's going to find it now. And once it finds it, well, let's see what happens. Let's see if it does find it and how soon that's going to happen.
There you go.
And now you can see that the train is moving around, and while it's moving, it's getting tracked.
Okay. Now I actually want this train for my granddaughter because she would love this. But
And,
okay.
and you can and put your hand somewhere, and you're a magician. You
yeah.
can stop a train with your
That's
bare hands.
very cool.
And once you stopped it, now it got reacquired.
All right, so there are some other companies out there that can also do charging at distance. Osea is one of them. Energous is another. What differentiates you from those other companies?
Right. So the number one thing that differentiates us is we use a different technology.
Yeah.
We use infrared light.
Yeah.
They use radio frequency light.
Okay.
As a result, and I'll explain why, we can deliver much, much more power, enough to charge a phone, at a much greater distance. And here's why. The first thing is that when we deliver infrared light, we can deliver a really narrow focused beam. I mean, think about a laser pointer. You could paint a tiny dot on a wall across the room with a laser pointer. So we use the same type. It's an invisible light, but it's still very focused. What does that mean? It means that if you have a small receiver, so for instance, one day maybe there's going to be a receiver here.
Right.
That means that you can deliver all the energy coming from the transmitter into that receiver. So you have very high efficiency, and you can deliver a lot of energy. In contrast, when you use radio frequency waves, they diverge, they open up. And that's really good if you're doing radio transmission because you want all the radio stations in your neighborhood to get that. But it's really bad when you do wireless power, because if you have a small receiver and you got a beam this wide, that small receiver is going to capture just a tiny, tiny, tiny fraction of the energy.
They do refer to it as trickle charging, indeed. So they don't claim that you're going to be able to charge at the same rate you might be able to do with even like a wireless charging pad that you lay your phone on, or certainly not hardwired.
But it's not only that. The other thing, if you're an engineer and you say, okay, I've got really low efficiency, my receiver can only take a small fraction of energy, you say, well, why don't I turn on the power? I deliver more power.
Right.
Well, it turns out that because RF is man-made radiation, the safety limits for RF are much, much, much lower than infrared. You know, 50% of the sun's energy is infrared. We as humans have been around infrared for so long, you know, we've adapted to it. So the bottom line is that we could deliver, you know, several watts of power at 15 feet easily, where none of the other guys, and it's not because they're bad, I'm sure they have great engineers, but they just use the wrong technology. You
Well,
cannot
I don't know
deliver
them
that
personally,
kind of...
so I can't say whether they're good or bad, but just kidding. So just in context, a wireless charging pad, today's fast charge wireless charging pads put out about 7.5 watts. This will put out how much?
So we've got two models, one that's for IoT that would put up about 1 watt, and we've got a bigger model that is geared towards mobile phones and mobile devices, could be tablets, could be, and which would do about 3 watts.
Okay.
So if you had an iPhone 10 and the iPhone 10 was completely empty, zero battery, it would completely charge in approximately 3 hours.
Okay. So you talked a bit about the difference between radio frequency and infrared and some safety concerns. So my question for you is this safe, and has it been approved by various government safety bodies?
Absolutely, it is safe. Now, in the US, we submitted it to the FDA. By the way, it's the FDA because if it's radio frequency, it's the FCC, and if it's light, it's the FDA.
Okay.
And the FDA determined that it's a Class 1 device. A Class 1 device is like your laser printer or your optical mouse. That means there are no usage limitations.
Okay.
And so Y-Charge today meets the safety standards both in the US and in most parts of the world today.
Okay, so it's, you could compare this with, say, a television remote control, for example.
In terms of the safety classification, yeah.
Okay. You also integrated it with one of the widest standards used in the business today, which is the QI standard for wireless charging. Can you explain how you did that?
Absolutely. So the problem was that people, one day you'll have these type of receivers or smaller versions integrated into the phone.
Right.
But today, they're not yet integrated into a phone. And we have lots of people who say, well, I want to use wireless charging today. So for instance, I run a coffee shop, and my customers want to charge their phones in a coffee shop. So today they have to find a table next to an outlet and remember to bring the cable, and that's not good.
Right.
Even if the tables have Qi chargers, magnetic induction chargers,
Yeah.
that these tables still need to be wired. But then you've got a table like this one that's in the middle of the floor. There's no power.
Right.
Not to mention, at the end of the day, it needs to be moved so the place could be clean. Well, what do you do? So we've taken a standard Qi charger, and we've added two things. One, we've added a battery here underneath, a rechargeable battery, and then we've put a Y-charge receiver right here with it. And so what happens is, I can take my phone.
Okay, so now what's happening is the transmitter has acquired this, right?
Right.
And it's transmitting power.
So the transmitter has acquired, so two things are happening at the same time. One is my phone, even if I block the receiver, my phone is going to get charged because that's now just a Qi charger.
Yeah, there's a battery in it. Yeah.
And at the same time, that battery inside could get charged overnight or while other things are happening, irregardless of this. Now, this is in this particular shape because now what a restaurant owner can do is you can place it basically at table level, basically flush with the table. You know, you could create a table where you have a hole for this, or we're looking at other physical designs where you just put it on the table like a condiment tray, almost like an ashtray, and then you can use tomorrow's charging technology with today's phone, because both Apple and Samsung now have Qi charging technology built into their phones.
So you're charging the wireless charger, is what you're doing?
Yes.
Okay, that's a very cool use. So last question, and this is the one that I think everybody tends to ask. People keep talking about wireless charging at distance. I'm not seeing any products. How far away are we from this being shipped?
So at the moment, we have several vendors who are integrating Y-charge receivers into their products. And they come in different areas. Some are smart home devices, some are more geared toward mobile. And we'll see these products announced and demonstrated this year. So some of the trade shows that I and probably you will be going later this year and very early next year, we'll have products that have Y-charge receivers built into them.
Okay.
And then they would hit the market, we presume, in 2019. That's up to whoever makes them, but that's the expectation.
So if I'm an IT director in a corporation, why should I care about this?
You can care about it for a couple of reasons. One, you may have a lot of sensors in your organization. It could be sensors on the factory floor, and it could be sensors in smart buildings. So for instance, why is a smart building smart? It's smart because it has sensors, and these sensors report temperature and humidity and where people are present and so on. Now, these sensors require power, and power require wiring. So you're spending a lot of time, a lot of money wiring these sensors. Instead, if you had a wireless receiver built into the sensor, you didn't need to do that. Now you need to move the sensor from here to there. It's not a problem. Just take it off and stick it there. So that's one reason you could care about that. The other reason, your employees may have mobile devices. They may have mobile devices like phones. They go into public areas, cafeteria, meeting room, they want to get charged. You may have electronic displays like in conference rooms. Or maybe your employees walk with augmented reality glasses and they need them to be charged. Or maybe you have tablets for data entry. All of these devices can now be powered with Y-charge without cables and without batteries. That's why you should care about it.
Okay. Thank you so much for coming by and demonstrating the technology. It was fascinating.
My pleasure.
All right.
Thanks very much.